Practice exam number 4, question 1. This is practice exam 4. Question number 1. So basically they want us to graph this function and also to answer a bunch of questions about the graph. So how do we graph? That's an x squared equation. How do we graph an x squared equation? X squared equations are always, x squared is always some kind of a U shape, either up if you have positive x squared, or it'll be going down if it's minus x squared. So U shape going up or down, it's a parabola, we call it, and it's a quadratic. This is called a quadratic equation. Quadratic just means x squared. And it's called quadratic because there can be 4 parts. See how you have the y, there's 1 part, 2, 3, 4 parts. So when you have an x squared, you have x squared, x, no x, and then the other side you can have 4 parts. That's why the name quad for quadratic. So an quadratic is an x squared equation, and the graph is always a parabola. It's either a U shape going up if it's positive x squared, or a U shape going down if it's negative x squared. This one's negative x squared. So we know we're looking for a U shape going down somewhere. But the key is to find the center. We got to find the center of that U shape. That's the most important point. That's the key to everything. So the center, it's also called the vertex of the parabola. The center, how you find the center, you want to have this formula on your notes for the exam. It's x equals negative b over 2a. Negative b over 2a. So, in fact, I think what I'm going to do is, here, let me just erase. Well, here, I'll just keep working, I'll erase later. So x is negative b over 2a. So, what's a and b and all that? We'll come in here, erase this. A is negative 1. B, not a 1, there's already an 8 there. B is negative 8. C is negative 15. So that's your A, B, C. So negative B, negative 8, right? Because B is negative 8, and there's a negative sign in the formula. Negative in the formula, negative 8 for B, all over 2 times A, and A is negative 1. So altogether we have 3 minus signs. So it's going to be negative, and 8 divided by 2 is 4. So x equals negative 4. And now that's the x value. Now we need to find y. So step 1 is use the formula x is negative b over 2a to find the center of the vertex. Step 2, plug in x is negative 4 to find the y value. So we have this equation up here which says y equals, bring it down to here, y equals negative x squared minus 8x minus 15. So we're going to take this negative 4, plug it in. So what do we get? We get y equals the negative from the formula. Now remember, when you plug things into a formula, put parentheses around what you're plugging in. Okay, so what do we get? This is going to be negative 4 squared. Negative 4 squared is 16, right? Because that means negative 4 times negative 4 is 16. Plus 32, 2 negatives make positive, minus 15. If you work that out, you can use a calculator. You get 1. Y is 1. So we got x is negative 4, y is 1. So that means negative 4, 1, x, y is the center or the vertex of the parabola. Let's go find that spot on the graph. So minus 4, so back 4, up 1, right there. That's the center. Back 4, up 1. That's the center of the parabola. So that's the most important point. We're almost done. Now, so step 1 is to find the x value. Step 2 is to plug in that x value to find your y value, which we did that. We got y is 1. And then step 3 is doing the rest of the graph. Now here I have a trick. It's my own little personal trick for step 3. A over 1 is a slope. I'll say it's like a slope. Let me change that. Is like a slope. So what's my A? Negative 1. So put that right here. So negative 1 over 1. It's like a slope, meaning you can do rise over run. So from the center dot here, if we go down 1, over 1, and you actually go over 1 both directions, because a parabola, unlike a line, goes both ways, right? It's a U shape. It opens right and left. So you go down 1, rise is negative 1. So from the center here, I started with the center. From the center, I go down 1, and over 1 both directions. So down 1 and over 1 both directions. That's going to be another point, and then just make your parabola go right through those 2 points, and you got it. There's the graph of the parabola. So that's all you need to graph the parabola. Now we can answer some of their specific questions. They're asking for the vertex. We've already got that. That's the center, negative 4, 1. And then they want the Y-intercept. Where does it hit the Y-axis? Well, we don't know, actually. I probably didn't do a very good drawing this, but it's probably going to go like this and eventually hit the Y-axis way down here somewhere. And it, same thing other side. It's symmetrical. So same thing other side. So they want us to find, this is the Y-axis, this is the X-axis. They want me to find way down here, where's it going to hit the Y-axis? Where's it going to hit the Y-axis? Well, let me come over here and erase some of this stuff and explain how you find Y-intercepts and X-intercepts. That's really important. Well, we'll do a lot of that in this section of the course. So, it's the x-axis here. So, when you're looking for a y-intercept, you set x equal to 0, right? Because like right here, the y-intercept means it's over 0 down some number. The x is 0, and we're looking for the y. That's what it means to be a y-intercept. Right? If you're a point on the y-axis, that means your x is 0. Your right and left 0 because you're on the y-axis. So your x is 0. So just take the formula. Y equals minus x squared minus 8x minus 15 and plug in x is 0. So y will just come out minus 15 because these two parts will disappear when they're 0. So it must hit down here at minus 15. So the y-intercept is over 0 down 15. Way down there at 15. Now how do we find x-intercepts? It's just the opposite. Set y to 0. Right? Because x-intercepts and y-intercepts, you always set the other letter to 0. You can see them right here. Now this one is actually automatically given to us. They're looking at us right there because of my trick of going down 1, over 1. So we've got them. But normally you would have to set y equal to 0 if it didn't coincidentally already have them. You would take the equation y equals negative x squared minus 8x minus 15, and you would plug in 0 for y. Whoops. And then you would have to solve. Now, how do you solve? Again, this is a kind of a silly one. We already know the answers. We're looking at them. But how do you solve an x squared equation? Well, we're going to have to jump all these guys to the other side. Because you want x squared to be positive. So step 1, get a 0 on one side and put, well, I don't have room to write step 1 there. Right over here. Step 1. So solving, how do you solve an x squared with an equal sign? What do you do? Step 1. So solving x squared with an equal sign. What do? Step 1, get a 0 on one side and move x squared to the side where he's positive. So I had to jump him to the other side. Remember, when things jump to the other side of an equal sign, they change their signs, right? I really just added x squared to both sides and added 8x to both sides, etc. All right, so we got it. Let's keep going. So these three just jumped to the other side. They changed their signs. And now, factor. Try to factor. If it doesn't factor, you can use the quadratic formula, meaning like the two parentheses. So do the two parentheses. X is in the front. What two numbers multiply to be 15? Well, 3, 5, and they, sure enough, they add to be 8. Right? And then each equals 0. So you take each one separately equal to 0. Now why? Why do we go from 1 equals 0 to 2? Why do we do that? Well, because it's the logic that if you have two things multiplying, right, parentheses are multiplied to equal 0, either one can be 0 to make that true, right? If I told you, hey, I'm thinking of two numbers, I times them and it comes out 0. What does that mean? Either one of those could be 0 to make those two things multiply to be 0. Either one could be 0. So that's what that means logically. So this first one is 0. Jump the 3 to the other side, -3. Jump the 5 to the other side, -5. There we go. There's the two X-intercepts. We can see them on the graph right there. That's the point -5 up 0. And right there, that's the point -3 up 0. So I'll just, there's the X-intercepts right there. I'll just draw arrows up to them. They want the domain. The domain on this one is, I'll come up here, the domain of a graph. Remember, that's how far left and right the graph goes. So, domain, I'll do it this way. Domain is how far left, how far right. Left edge, right edge. So what's the domain of this thing? Well, that's this graph. The branches, the arrows go down and left or right forever. So -infinity is the left edge. And regular infinity is the right edge. Left edge, right edge. It goes from -infinity, it goes forever down and left, forever down and right. What's the range? So range is bottom, comma, top. So bottom, comma, top. So range, if I can write it like this, range is how far down, how far up does it go? What's the bottom of this graph? Well, it goes down forever. -infinity. What's the top? The top is right here. This is the top, which is out 1, isn't it? And it's a bracket because it hits the 1 straight on, not a parenthesis. It doesn't just get close to 1. Remember, parenthesis means you just get around it. Bracket means you're straight on it. So from -infinity to 1. And then the last thing they want is they want us to give them the equation of the axis of symmetry. So that's the line that goes right down through the middle. This line right here. Right there. And you can see where that hits if I don't scribble it too big. Right there. It hits the axis. Well, here, let me put it down at the bottom. The axis of symmetry. That's the symmetry line, the line that splits the graph. That's x equals -4 because it hits the x-axis right through the middle at -4. It goes right through the middle of the whole. It splits right through the middle of the whole U-shape, the parabola at x equals -4. It goes right through the center. It's just the x value of the center of the graph. There we go. Number 2. So they're asking us on this graph, this equation, to graph it. Now this one has parentheses, so it's a little different. So this is graphing x squared with parentheses. It's easier. So the last problem, number 1, notice there were no parentheses, were there? So it was harder. This will be easier. So all you do, let me write it. You just go x minus 4 squared minus 1. It's nice and simple. It's all about finding the center again. We got to find the center. the center will just be handed to us. It's the opposite of what's next to x, comma, the same as the number out there. So it'll be opposite of -4, +4, and same as -1, -1. That's the center. Over 4, down 1. Right there is the center of that U-shape, parabola. So it's that quick. I don't have to plug in the formula x equals -b over 2a or any of that. When you've got parentheses squared, it's really easy. Just take the opposite of what's next to x and the same as the other number. That's your x and your y, and you got the center. We're almost done. So remember how we're always taking the opposite of whatever's next to x. That's pretty much what we're always doing. Now, so that's step 1. Step 2, a over 1 is like a slope. Remember? Same thing as the last one. A over 1 is like, now what's a? I don't see. Well, the number in the front. So what's in the front? It's just 1. There's nothing in the front. Invisible, understood 1. That's our a on this one. So it's 1 over 1. That's rise over run. So from the center point, you go up 1, over 1. And remember, you go over 1 both directions because these parabolas open up both directions. There we go. We got it. There's the graph of the parabola. It goes up because the a is +1. If the a was -1, if the number in the front was -1, it'd go down. Or any negative number, it'd go down. Vertex, like what's the center right there? We got it. It's 4, -1. And what's the equation of the axis of symmetry? That's the line that goes right through the middle here. So that's x equals 4, right? Because it goes right through the x-axis at 4. It's always x equals the x-coordinate of the center because it goes right through the center of that. There we go. So it's a lot easier. We're done with that one already. It's a lot easier when they have parentheses squared. So make sure for the exam you know those two different forms, the kind with the parentheses squared and the kind that has no parentheses where you got to use the formula x equals -b over 2a. That's what we had to do on this one to find the center. It was a lot harder. Number 3 here. So write an equation. Now we're working backwards. So they're going to give us the U-shape, the parabola, and they want us to come up with the equation of the thing. Well, here's the center. So we know, remember how the parentheses work. X squared, and then so there's some number here, and there's some number here. And remember, this is always opposite, same. Opposite, same. So what's the center? Over 2, up 0. So 2, 0, the center, the vertex of the parabola is 2, 0. So the opposite would be -2, because that's a +2. And then 0 plus 0 out there. So in other words, and I should say, we could have some number in the front, call it a. We don't know what that is. So right now we know the equation is, so step 1 is, we know this much. So it's a times x minus 2 squared. We don't know what the a is yet. The 0, I just got rid of that because it's just 0. So now we have to find a. So step 1, we just do opposite, same of the center. The x value of the center is the opposite next to x. The y value of the center goes off to the right. Opposite, same for the parentheses squared. Now, how do we find a? Well, probably the best thing is just to go over here and use the y-intercept. 0, 2. So step 2, plug in the y-intercept, 0, 2. So x is 0, y is 2. So plug them in. So I'm going to take the 2, pop it in there, the 0, pop it in there. 2 equals a times 0 minus 2 squared. So that's 2 equals a times 4, right? Minus 2 squared is 4. How do you solve there for a? Divide by 4. Boom. A is 0.5. 2 divided by 4 is 0.5. So we have it. There's the answer. Y is 0.5 because the a in the front now is 0.5. x minus 2 squared. You can put the plus 0 at the back if you want or not. It doesn't do anything whether you have it there or not. So we find the opposite same for the parentheses squared, and then we find the a by plugging in the y-intercept. Number 4, they want us to take this equation and put it in that form. So how do we do that? That's actually kind of tricky. So to make that happen, what we need to do, okay, this one can be a little tricky. So let's do this. Let me write it down here. So step 1, subtract the 12 over. So I'm gonna get rid of this number here from both sides. So we get y minus 12 is x squared plus 8x. What we're trying to do is we're trying to write it as parentheses squared without changing it. We're trying to change the way it looks without changing its value. So next step is take the middle, or take the b. Let's just call it b. The middle number. Yeah, I'll say middle number. The middle number, the b, over 2 squared added to both sides. So I'm going to take this number here that's in the middle. I'm going to put it over 2 squared. What's that? 4 squared. 16. I'm going to add 16 to both sides. Right? I'm doing the same thing to both sides of the equation, so nothing will change. What do I have over here? Y minus 12 plus 16. The other side, x squared plus 8x plus 16. Let's simplify it. This is y plus 4. This side we factor. So that's step 3. Yeah, I probably should have. Here, let me do that. Let me write step 3. Factor the right. So the left side, will just simplify y plus 4 because minus 12 plus 16 is plus 4. The other side factors, and how does it factor? Plus 4 plus 4. So it multiplies, that means it multiplies to be 16, it adds to be 8. So in other words, it's y plus 4 is x plus 4 squared, because that's the same thing twice, right? So it's squared. Last step, they want y alone, so just jump the 4 over here, and it becomes a negative 4, right? When things jump to the other side of the equal sign, they change their signs. There we go. There's the answer. That's the same. What did we just do that for? It's the same as the original. If you were to multiply that out, it would turn out to be exactly the same as the original. Let's prove it real quick. What if I was to take x minus 4, or plus 4, squared minus 4? You'd have to multiply that out. I don't know if you know, squared, you got to write 2 of those, right? Got to write 2 of those, and then we got to multiply, so you go boom, boom. That'd be x squared plus 4x, boom, boom, plus 4x plus 16 minus 4. That's x squared. 4x and 4x is 8x. 16 minus 4, 12. See how that's the same as what we started with, the original? So in other words, this is the same thing. It just looks different. It's just in a different format. Well, why would we want to do that? Well, remember how nice parentheses squared format is for graphing back on question number 2? It's also good for other things in higher math. So we like to change formulas that have an x squared. We like to change them to actually have a parenthesis x squared. It's very convenient. So how do we do it? You first, by subtracting the 12 over, you get just the x squared and the x on one side, and then you take the here's the magic part, the middle number over 2, right here, middle number over 2 squared, that's 4 squared, 16, and you add that to both sides. That does the magic. That makes the left side, what that does, that gives the left side just what it needs to factor as a square. That's it. That works perfectly. So the right side will factor as the same thing twice, which means squared. That's what made it happen. There we go. So, we got to do number 5 down there. Write an equation for the quadratic graphed below, and I just drew all over it. Okay, so here's number 5. They want me to write an equation for this graph. So, how can I write an equation? Well, you know it's a parabola. So, it's going to be A, and the best way to write this is to notice these are X-intercepts. Those are places that hit the X-axis, aren't they? So what that means is X opposite plus 3 and X opposite minus 2, right? The opposite of minus 3 is plus 3, that's opposite. And the opposite of plus 2 is minus 2. It's got to be that way. When X-intercepts, places where a graph hits the X-axis, end up like that in the parentheses. Now why do we know that's the case? Well, because this point is actually 2, 0, isn't it? And this point is actually minus 3, 0, the X and the Y, the X and the Y, which means if X is negative 3, for example, right? X is negative 3. If you plug in negative 3, what are you going to get? What is negative 3 plus 3? It's going to be 0. And you plug in negative 3 there, you get negative 5. So what is any number times 0 times negative 5? It's 0. Y is 0, isn't it? If you're multiplying 3 things together and one of them is 0, it multiplies out to be 0. So my point is, when X is negative 3, Y is 0, which is right, negative 3, 0. You see how it works? Or if you put in positive 2. What if you put in positive 2 to both those? What is Y going to equal in that case? It's going to equal 0 again. Do you see it? Because this is going to be 2 plus 3, which is 5, but this is going to be 2 minus 2, 0. So it's going to be A times 5 times 0, it's 0. So do you see, by putting the opposite of X next to X in each of the parentheses, we make these guys be X-intercepts. Meaning if you plug those X values in, Y will be 0. Height of 0 on the X-axis. So that's how you start off. So in general, in fact, probably I should write off that general game plan. Whenever you have Y equals AX, X, and you do opposite and opposite for X-intercepts, the opposite and the opposite of the X-intercepts. Always go there. So that's a good thing to put on your notes for the exam. So it's the opposite of negative 3 plus 3. It's the opposite of negative 3, opposite of plus 2, minus 2. Okay, so now all we got left is to figure out what A is. How are we going to find, so that's step 1. Step 2, you know what we're going to do, right? We're going to plug in the Y-intercept. It's all about the intercepts here. Plug in the Y-intercept, which is right there, which is over 0 minus 2, isn't it? XY over 0 minus 2. So over 0 minus 2 XY to this equation, Y equals A, X plus 3, X minus 2, and we can find the A. So plug in 0 for X, plug in negative 2 for Y. We get negative 2 is A. 0 plus 3, 0 minus 2. A times 3 times minus 2. And so minus 2 is A times minus 6. Finish solving for A, divide by minus 6. That 2 negatives make positive. Reduce that fraction. A is 1/3. So our answer is Y equals A. x plus 3, x minus 2. The a we now know to be 1/3. There's the equation of that U-shape, that parabola. Good. All right, so let's go on to number 6. The height of a ball thrown by a child is that formula where x is the horizontal distance which the ball is thrown. How high is the ball when it leaves the child's hand? Well, I'm going to go back to where we get some room to work on this one. So, y equals minus 1/12 x squared plus 4x plus 5. Okay, so they're asking apart, so basically let me draw a little graph of this thing. We have a graph here, x-axis, y-axis. This is the y-axis, this is the x-axis. The child standing here and throws the ball, and then it eventually hits the ground, right? So that's the idea. The child throws the ball. So what are their questions? Part A. How high is the ball when it leaves the child's hand? Height of the ball when it leaves the child's hand. So that'd be right here. How high is the ball right there? Well, this is an axis system, right? This is over 0 up some number. That's x0. Try to find y. X is 0. What is y? That's the height of the ball when it leaves the child's. It's x0. So plug in x is 0. Right? At that point, right when it leaves the child's hand, the x is 0. So take our equation and plug in x is 0. These guys drop out, and y is 5. The ball must be at a height of 5 when it leaves the child's hand. There we go. Part B. What is the max height? The max height of the ball. So these are physics questions, really. And so what I'm going to do is I'm going to try to be real. Where is it? Look at the picture. Right there. So that's the max. That's the max height of the ball, isn't it? So I need to find that point. That's over x up y, some point. I don't know. What is it? It's the center of the U-shape. You see, it's a parabola. It's the center of the U-shape. We have a formula for finding the center of a parabola. The vertex. Remember the formula for the vertex? The center, whatever you want to call it, same thing. It is x equals negative b over 2a. Negative b over 2a. That's how we find the x, and then once we get that, we'll have to plug in to get the y. What's the x? This is a, b, c. So negative b, negative 4 over 2 times a. So how should we do that? Well, it's a little messy. It's negative 4 over, so this is 2 over 1. So 2 goes into 12 6 times. That's 1/6 on the bottom. And then grab that 1/6 and flip it up. So it's negative 4 times 6 over 1. It's negative 24, right? When you divide by a fraction, dividing is upside down multiplying. So you flip up that 1/6 to be 6 over 1. And then you multiply. So it's negative 24 over 1. So that's just negative 24. So negative 24, that's the x value. So it's x is negative 24. Oh, actually, it can't be negative. You know what I forgot? Let me do this again. I forgot that the a is negative 1/12, not positive. So that should come out positive 24. Let me redo it to be super clear. So again, it's negative b over 20. So negative b, which is 4, over 2 times a is negative 1/12. So on the bottom, again, this is 2 over 1. 2 goes into 12 6 times. It's negative 1/6 on the bottom. Two negatives make positive. Fraction on the bottom flips up, and it becomes, this is x equals 4 times, you write dividing is upside down, multiply by 4 times 6 over 1, 4 over 1. That's 24 over 1, and 24 divided by 1 is just 24. So x is 24. That's the x value. That means this is over 24. But they asked me what the height is. I want to know how high up. I know the x is 24, but what's the y? How far up is that ball? Well, for that, we're going to have to plug in, aren't we? Take y, take the original equation, minus 1/12. X squared, and plug in. Plug that in. 24 squared plus 4 times 24 plus 5. So plug in that 24. 24 squared, use my calculator, I think it's something big. 576 over 1 plus 96 plus 5. So if you divide, 12 goes into 576. I'll divide it here. Is that 48 times? So 48 plus 96 plus 5. I'm getting y equals 149. Oh, wait a minute. Did I forget the negative again? I did. Let me check. I'm going too quick here. So that should be negative 48 plus 96 plus 5. So y equals 53. Y is 53. So the height is 53. So that was a lot of work to get that maximum height of the ball. We had to realize that at the maximum height up there, that was going to be the center of a U shape, right? That's a U shape going down. That's a parabola. And at the peak, the formula is x is negative b over 2a. Found x, 24, plugged it in for y, and solved that out and found y is 53. That's the maximum height of the ball. Now, last question is, let me go to part C here. Part C. How far from the child will the ball hit the ground? How far? So they're talking about right, talking about way over here. It's going to hit the ground. So think about, so when you're doing physics, try to be real. What do we know about that point when it hits the ground? That's over some x value, I don't know, up 0, isn't it? The y value has to be 0. Its height is 0. When it hits the ground, its height is 0. Its y is 0. So it's the point over x up 0, meaning the y is 0. So plug in y is 0. Do you see how we just look at the real life points and we decide what to plug in? Like back here, we said, well, when the child releases the ball, the x value is 0. Over here, when it hits the ground, the y value is 0. Its height is 0. And at the maximum, we use the formula for the center of a U shape. X is negative b over 2a. All right, so getting back to the formula. So we got to plug into that formula. So y equals negative 1/12 x squared plus 4x plus 5. I'm going to take that 0, pop it in. 0 is minus 1/12 x squared plus 4x plus 5. Okay, now what am I going to do to solve for that thing? Well, we do not want fractions. Fractions are a big pain. So let's get rid of fractions. We don't want a minus 1/12 there. So let's multiply through by 12. But remember, if you multiply one part of an equal sign, you got to multiply all the parts. Left side, right side, everything. 12 times 0 is just 0. The 12s cancel here. We get minus x squared. 12 times 4 is 48x. 5 times 12 is 60. There we go. So we factored it on that. So Now we're going to plug into the quadratic formula. That's how we solve an x squared, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. So plug into the old quad. So negative 1 is a, b is 48, c is 60. So negative b, negative 48 plus or minus the square root of b squared. 48 squared minus 4 times a times c all over 2a. And a is negative 1. Be careful there. Okay, let's work it out. Let's keep it going here. Negative 48 plus or minus squared. 48 squared on the calculator. Big numbers. 2304. 2304. Now plus, because it's minus times plus. Two minuses make plus. 4 times 6 is 24, so 240 over negative 2. All right, this is getting messy. And we come up here, so this is x equals negative 48 plus or minus the square root of plus 240. So I'm getting 25, 44 all over negative 2. Okay, so we have two options here. We got to just do those two separate options. We have negative 48 plus the square root of 2544 over negative 2. Type that into your calculator. Make sure to remember to hit equals when you're done with the numerator before you divide by 2. Negative 48 plus the square root of 2544 equals divided by negative 2. I'm getting the answer negative 1.21. And now let's do the second option. Negative 48 minus the square root of 2544 over negative 2. Again, make sure you hit equals when you're done with the numerator before you divide by 2 in the denominator. So negative 48 minus the square root of 2544 equals divided by negative 2. I'm getting 49.22. So we got two possible x answers. Why? Well, if you go back to the picture, if you look at that parabola, if you kind of let it extend to the other side, it's actually going to hit right here and right here. This one is actually back. That's the negative answer, 1.21, up 0. This one right here is over 49.22, up 0. Now, we don't want the negative one. See, math is just a tool. Math is not real. Math is just made up tool to help us describe things that are real. So this child is throwing a real ball, and it's really hitting the ground right here, 49.22 feet away from where he released the ball. What's this negative answer? Well, that's if the ball could continue on the same U-shaped parabolic arc, and went backwards in time, it would have hit 1.21 feet behind him. But of course, we don't go backwards in time. Math doesn't know that. It's just telling us the other place where the parabola would be a height of 0. We ignore that answer. That's not in real life. The real life answer is the 49.22. So that's the real answer. That's where the ball hits. Number 7's about a graph. We've got this polynomial graph. It's got a lot of shifts. Basically, when they talk about least possible degree, the lowest degree is number of turning points plus 1. In other words, you find out how many. Here's a turning point right here. It goes from going down to up. Here's another turning point, and another turning point. There's 4 turning points. Add 1. the lowest degree is 5. In other words, this has got to be x to the 5th or higher. We don't know, 7x to the 5th minus 2x to the 4th plus 3x squared minus plus 7, whatever. I don't know, but it's got to be x to the 5th, or it might even be higher. The lowest degree that this polynomial, that graph could possibly be is x to the 5th. It could be even higher, but if it's got 4 turning points, it's got to have at least a 5th power. So that's how you know that. If you think about it, it fits what we know about a U-shape. What do we know about a U-shape? U-shape has 1 turning point, and it's always x to the 2nd power, isn't it? So in other words, the degree is always 1 higher than the number of turning points. At least. It could be even higher. Right? That fits what we already know. The degree is always 1 higher than the number of turning points. So if you've got 4 turning points, then you got to be at least 5th degree on that one. So, number 8 down here in the bottom. The polynomial of degree 3 has a root of multiplicity 2 at x equals 4. So what that means is it's some kind of constant a, and a root is a fancy word for an X-intercept. X-intercept, which means it's opposite. 4, so it's going to be minus 4. Multiplicity means the power, 2 power. Next one, multiplicity 1 at x is negative 5, so that'll be x plus 5, first power. Does that make sense so far? We still got to find the a. We're not done. But is that making sense? Roots are a fancy word for X-intercept. Root means X-intercept. So, in other words, this graph hits over at 4 and back at negative 5. Does something like that. It does something like that. And it might look like something like that. So the graph has an x-intercept at negative 5. Remember, we always do opposite of x whenever we put it next to x in the parentheses. The opposite of plus 4 is minus 4. The multiplicity is the power, right? It means, a power is how many times it's multiplied. Like 7 to the 2nd power, that means 7 multiplied twice, doesn't it? So the multiplicity is the power. So now we have to find a. How are we going to find the a that goes in the front? Well, you know what we do to find a. We always do the y-intercept, don't we? So let's do it. So the y-intercept, negative 8. That means that's the point x is 0, y is negative 8. Remember, an intercept always has the opposite letter being 0. So a y-intercept has x0, an x-intercept has y0. So plug in that information. So we'll take the equation. This is y on this side, isn't it? The function, the p of x or f of x or whatever is always y. So we have y equals a x minus 4 squared times x plus 5. And we're going to plug in negative 8 for, right there, I'm going too far. We're going to plug in negative 8 for y and 0 there and there for x. So we get negative 8 is a times 0 minus 4 squared times 0 plus 5. Negative 8 is a times 16 times 5. Negative 8 is a times 80, like that. And so then divide both sides by 80, divide by 80, divide by 80. These cancel. A is negative 0.1. So there's the answer. There's how they got that negative 0.1. in the front. So remember, roots are x-intercepts, and x-intercepts, we always put the opposite number next to x in parentheses. The multiplicities are the powers. And then to find a, plug in the y-intercept to find a and solve the equation for a. Number 9. Given that function, find the y-intercept. So how do we find a y-intercept? An x-intercept. I think I'm going to go where I got some room here. Let's go back here for number 9. So for number 9, a little bit of room. We've got, I'm going to just go y equals, the function is just y, x minus 2 squared, x minus 5. And we want to find the y-intercept. Well, again, intercepts always mean opposite letter 0. Plug in x0, y-intercept, right? Because if you have a graph and it has a y-intercept, there's a y-intercept. This would be an x-intercept, right? To be a y-intercept means you're over 0 up some number, means your x is 0 and your y is whatever it turns out to be. Your x has got to be 0. That's why the opposite letter is 0. It's just the very meaning of being a y-intercept. So take the equation, plug in x0, and we get, what's that going to be, 4 times minus 5 minus 20. So the y-intercept is minus 20. You want us just to leave it just like that. So next we're going to find the x-intercepts. And again, opposite letter 0. So plug in y is 0. That's what it means to be an x-intercept. You're over some number up 0, right? Your x, y, your y has got to be 0 at an x-intercept. If you're hitting the x-axis, your y value, your height is 0. So plug in y is 0. So take that same equation, plug in 0 for y. Okay, now how do we solve that? Well, you set each one equal to 0 separately. Why? Well, because if two things are multiplying to equal 0, right? Track back here with me. Something times something is equaling 0. How can two things multiply to equal 0? Well, either one could be 0 to make them multiply and be 0. Then finish solving this one. Square root cancels out the 2. Square root of 0 is just 0. And then add 2 to both sides. X is 2. This one, add 5 to both sides. X is 5. So the x-intercepts are 2 and 5. Now they're asking us about x going to infinity for this one. When x goes to infinity, where does y go? And right, so as x goes to infinity. Well, infinity, I'm just going to plug in like 100. That's just a big positive number. I'm going to take our formula here, our equation, plug in 100 for x. See what I get. I'm going to get, what's that, 98 squared times 95. You do that in your calculator, you get something gigantic. And I'm getting 912,380. So the point of the matter is, it's going to positive infinity, right? I'm only at 100. They want me to go to infinity, so that'd be 1,000, 100,000, a million. There's a million. You know, it's just going to get bigger and bigger and bigger. Positive, this is positive answer, right? Positive infinity. So as x goes to infinity, y also goes to positive infinity. Now, vice versa, now they're saying, okay, how about as x goes to negative infinity? Does that automatically mean y will go to negative infinity? Maybe. Sometimes yes, sometimes no. So what we're going to, again, plug in x is, this time, negative 100, because x is supposed to go to negative infinity. So I'll plug in negative 100. Y equals negative 100 minus 2 squared times negative 100 minus 5. So that's negative 102 squared times negative 105, huh? So multiply that out. So 102 squared. I'm getting negative, because there's three negatives, right? These two negatives is positive, then another negative, it is negative. 1092420. So it's 1,000,000. It's negative infinity. Y is going to negative infinity on that one. Number 10 gives us a graph. So on this graph, they want me to write it in factored form, like you can see the answer down here. So it's going to be y equals a. Remember what you do. You go x parenthesis, x parenthesis, x parenthesis, and these always are opposites of the x-intercepts. Opposites. So what are the x-intercepts? There, -4, -3, there at 1, there at 3. So it's y equals a. So it's the opposite of -4, +4, opposite of -3, +3, opposite of +1, -1, opposite of +3, -3. Now we just got to find the a in the front. How do we always do that? The y-intercept, which is over 0 up 1, the x and the y. Plug in the 1 for y and the 0 for all those x's. Okay, so what do we get? That's a times 4 times 3 times -1 times -3. What's that? 12 times 3, 36, and it's going to be positive 36. Finish solving for a. Divide by 36. A is 136. So that's what goes in the front. And then there's all the rest of the x's with the numbers next to them. Are the opposites of the x-intercepts. Okay, and number 11, same kind of deal. So I've got to let you know about three important things here. Basically, when a graph, let's list them out over here. When a graph passes through like that, say it, here, let's suppose we have a graph and way over here at, 5. That's going to be x minus 5, because it's always opposite. This is +5, so opposite. To the, here, let's make it 6. I don't like 5. So say this hits at +6. Then you're going to have y equals x minus 6 to the first power. So first power picture. And then another thing that can happen is way over here. It can go like this. It can be coming up and bounce. Sometimes it'll bounce at +6. That'll be y equals x minus 6 squared. So when it bounces, that's second power. When it passes through, that's just first power. And you know that, right? Because you know an x squared graph, that's y equals x squared. It's a U-shape. It's a bouncer. No big surprise, right? Whenever a graph bounces, I'm talking about like right there, that's a bounce point, isn't it? See on the graph we have, that's a bounce. So now, there's a third and even more tricky situation. Way over here at 6, it could do something like this. It can be coming up and sort of hit and not come back down, but instead kind of do a squiggle. See how it like squiggled through? So at 6, at +6, so that's going to be x minus 6 to the third power. It does a shift. It passes through with a shift. Let me write it that way. it passes through. So it doesn't bounce, so it's not second power. It didn't come back down, but it passed through with a shift. See how the graph shifted a little bit? See how it was kind of like it was coming in. And let me draw this a little bit. Let me draw the shift a little better. There we go. See how it was coming in like a bowl turned down? This part is what we call concave down. It's a down. It's concave down. It's like a bowl turned down. And then it comes out of the graph like a bowl turned up. It shifted its concavity there. It didn't bounce down, so it's not squared, but it had a shifting concavity. Whereas this one back here just passed right through. He's up all the way. He's concave up, going up all the way. Whereas this one came in concave down and then came out concave up. That's third power when it does that. So you got to have those on your notes for the exam. So what does this mean then? So we have y equals, it bounces at -3, bounce, that's the second power. So it's opposite. Well, first off, we got to have an a in the front. We always have some kind of number in the front. Opposite of -3, it's going to be +3. And it's going to be second power. Second power because of the bounce, like x squared, U-shape. And then it also hits over here at 4. So that's going to be -4, opposite. Whenever it's next to x, it's the opposite. And this one is a shift, isn't it? See how it comes in like a bowl turned down? It's concave down, we call it. And it comes out up, concave up. That's a shift. That's third power. This one right here is third power because of the shift right there. All right, so there's our setup. Now we have to solve this equation for a. And you know what we do? We plug in the y-intercept, right? Over 0, down 4, xy. Plug in 0 minus 4. This is x, this is y. So plug in y right there. So we get, what do we get? -4 is a, and x is 0. 0 plus 3 squared. 0 minus 4 cubed. A times, this would be 9. -4 cubed. -64. What is 64 times 9? I'm getting -576. Solve for a. Divide both sides by -576. And you use your calculator. 2 negatives make positive. 4 goes into 576. Divide by 4. 1 over 144. So there we go. It's 1 over 144. X plus 3 squared. X minus 4 cubed. They wrote them out. You can do it either way. I just like putting the powers on them. I think it's easier. They wrote 2x plus 3s and 3x minus 4s. Whatever. I like it better like this. It'll take it either way. So there we go on that one. Number 12. So now we're looking again at a graph and the whole multiplicity thing. So let's go through it answer by answer. So right here, it passes through. There's no shift of any kind. Just goes straight through. Power equals 1. So power, that's the multiplicity. Multiplicity is power, right? Power is how many times something's multiplied. What about right here? At x is 0, that's x is 0, and it bounces, doesn't it? Let me change the color there. It bounces at that spot. So what does that mean? Power, when you bounce, your power's 2. Oh, whoops, so I can't put the 0 there. I guess I got to put the 0 there, power 2, because they have another one with power 1 I guess I've got to find. So what's the other? That means this one. X is 4, power 1. Yeah. So there we go. They kind of controlled what order I put them in. So that one's not too bad. Just checking if we know how that works with the powers and the multiplicities there. All right. Number 13. So now they want us to look and kind of work it backwards. They're asking for the roots. Roots are X-Intercepts. It's just two names for the same thing. Roots are X-Intercepts. So what's the X-intercept here? Remember, it's opposite. Whenever you put a number next to X or N or any letter in parentheses like that, it's opposite. So the opposite of negative 4, plus 4. The opposite of plus 1, minus 1. The opposite of minus 5, plus 5. There's the roots. You can list them in any order with commas. And then their multiplicities. What's the powers on them? 8, 7, and the last one, 1. There we go. That's not too bad on that one. Oh, we got to do 14 down here. So 14, they want us to write a polynomial that fits the situation. So again, we're practicing with this. Remember, it's X, parenthesis, and it's going to be opposite of the X-intercepts. Or they're also called zeros or roots. They have a lot of names. So X-intercepts are also called zeros. They're also called roots. So here they're calling them zeros. So they're saying, okay, we got 3 of these. So we got 1 here, and 1 here. So they're saying, got to do the opposite. So the opposite of 0 is minus 0. The opposite of minus 4 is plus 4. The opposite of 3 is minus 3. And then the multiplicities are the powers. So the zeros are the X-intercepts. And the multiplicities are the powers. So what are the powers? 2 on the first one, 1 on the next one, and then 3. Now, x minus 0, we're just going to make that x. So that's just going to be x squared, because x take away nothing is just x. X plus 4 to the first, x minus 3 to the third. There we go. 15. Find the quotient and remainder using long division. All right, this is a little painful. Going to do some long division here for 15 and 16. Let's get some space. So number 15. I'm going to turn this into a long division problem. 2x squared. You put the bottom over onto the left. And we've got 2x to the third minus 10x squared plus 7x minus 20. Okay, here's the deal. These are kind of tricky. You've got to put up here whatever will multiply the front to match that guy. So what times 2x squared will match 2x to the third? X will, right? So let's do it. So that x is going to multiply both these. X times 2x squared is 2x to the third. X times 5, 5x. Draw your line, and now we're going to subtract. We're supposed to subtract. Remember, long division, we always subtract. So how am I going to subtract those? Well, that minus sign in front of the parentheses, go ahead and let it distribute in there. So that'll go here, make this negative. Go here, make this negative. So 2x cubed minus 2x cubed, that'll cancel. We always want that to happen. Perfect. Minus 10x squared, I should have put the 5x over here, shouldn't I? It was a plus 5x. You should line up the same powers with the same powers. So this was a plus 5x at first, but then that minus sign changed it to be a minus 5x. So I'll just bring down the minus 10x squared. And now plus 7x minus 5x is 2x. Bring down the minus 20. All right, there's the first step. Next step. What am I going to put here? That'll multiply the front and match the front. You've always got to multiply the front to make an exact match with the front. What times 2x squared makes negative 10x squared? Negative 10. No, negative 5. Negative 5. So negative 5, and it's going to multiply both those. So negative 5. Let me move that here. Negative 5 times 2x squared is negative 10x squared. Negative 5 times negative 5 is negative 25. Put it over there underneath the other number. So now you know what to do. We got to subtract, with parentheses, you got to subtract that whole denominator from the numerator, from the top. So that means that minus signs again is distribute, make that plus, distribute, make that plus, right? It changes both the signs. Minus 10x squared plus 10x squared is 0. That should always happen. Bring down the 2x. Minus 20 plus 25 is plus 5. And that is our remainder. So the quotient is the top up here. And the remainder is the 2x plus 5. There we go. Let's try another one of these. We have number 16. So we're going to long divide 4x plus 1 into minus 16x to the third plus 16x squared plus 13x plus 0. Okay, so again, whatever we put up here, times the front to match the front. What times 4x will exactly match, same sign, same everything, negative 16x to the third. Well, we need negative 4x squared. And it'll multiply both those, won't it? And what do we get? Negative 16x to the third. See, it's an exact match. We make it that way on purpose. Minus 4x squared. But then we subtract, right? That's long division. You multiply and then you subtract that whole line. So that minus sign's going to distribute, make that plus, and make that plus because you're subtracting the whole line. Now they're opposites. Minus 16x squared plus 6 cubed plus 16x cubed. They cancel. See how that always works? We make it the same at first, then the subtraction makes it opposite. Plus 16x squared plus 4x squared is plus 20x squared. And then bring down these guys. Plus 13x plus 0. Next step, what are we going to put here? What times the front will match the front? What times 4x makes 20x squared? Well, it's going to be plus 5x. That'll multiply to be 20x squared plus 5x. Draw your line. Now we've got to subtract that whole line, but it's gonna negative's gonna go there, negative's gonna go distributes in, and you're subtracting the whole line. So now 20x squared minus 20x squared is 0. 13x minus 5x, what is that? 8x plus 0. One more step. This is not the remainder this time because we can do another step. What do I mean? I mean there is something that'll work. In other words, we're asking here, what times 4x will exactly match 8x? Well, 2. There is something. So we do another step, and that 2 is going to multiply both these. So what are we going to get? 2 times 4x is 8x. 2 times 1 is 2. Draw your line. Subtract that whole bottom line. That means the minus goes there and there. 8x minus 8x is gone. 0 minus 2 is negative 2. So the quotient is the top up there. You know, it's right up there. Minus 4x squared plus 5x plus 2. It's the main part of the answer. And the remainder, minus 2. We got it. So those are not easy. Okay, 17 is synthetic division. So instead of long, let me cross off long. No more long division. That was 15 and 16. Now 17 is synthetic. That's way better. What you do is you take the number down here and you take the opposite. So that'd be negative 2. And you draw a big thing like this. You put negative 2 here. You take these coefficients. 1 plus 7 plus 14 plus 10. And now you bring down the first number, 1, and then you swoop this way and you multiply. Negative 2 times 1 is negative 2. Then you add them up. Plus 7 minus 2 is 5. And then you swoop again. Negative 2 times 5, negative 10. Add them up. 14 minus 10, 4. Then you swoop again. Negative 2 times 4, negative 8. Add them up, 2. So then you turn these back into x's. So you say this is 1x squared plus 5x plus 4, remainder 2. See how I put a box around that last? That last one is always your remainder. So there's our answer. X squared plus 5x plus 4, remainder 2. Way easier than normal long division, isn't it? Let's try another one. So number 18, same thing. You take the opposite of this number, plus 2, right? Because whenever a number is right next to x, we always take the opposite of it. You've seen that pattern now a few times. So plus 2. And then we write down the coefficients. 1, negative 5. And then notice x squared is missing, so that's 0. You can't skip anybody, so there's a 0x squared. Then next comes a plus 10x, just the numbers, and then the 0 at the back. All right. You bring down the first number, and then you multiply. 2 times 1, you write it right here, 2. Add them up. Minus 5 plus 2 is minus 3, and you swoop again. 2, you multiply 2 times minus 3, minus 6. Add them up, minus 6. Do it again. 2 times minus 6, minus 12. Add them up. 10 minus 12 is minus 2. 2 times minus 2 is minus 4. 0 minus 4 is minus 4. That's your remainder. That last spot is always the remainder. What are the other spots now? We start, this is 1x cubed minus 3x squared minus 6x minus 2. There it is, remainder negative 4. Much nicer than the other way on that one. All right, so number 19, find all the zeros of that function. Okay, so let's give that one a try. I'll get some fresh space back here. So on number 19, f of x equals 8x to the third minus 6x squared minus 45x plus 50. Okay, now on the actual exam, what I'm going to do is when we did the homework, I had you graph it on your graphing calculator or Desmos.com. You can go to Desmos.com. It's a free math website. Just type it in and graph it, and you'll see that one of the zeros is x is 2. Like when you look at the graph, over at, say this is 1, 2, you'll see that the graph hits at x equals 2, or probably passes through. Here, let me not kind of... You'll see it looks something like this. Here, I'm not doing the graph. What you'll see at Desmos.com, if you go over there, is you'll see here's 1, here's 2. You'll see the graph goes off this way forever, and it hitting right at 2, and then somewhere over here, and then somewhere way back here, -1, 2 hits right here, and then kind of like that. So that's the graph you'll see. So you can't tell exactly what that 0 is. You can't tell exactly what that 0 is, but that one's clear too. On the exam, that's what you'd see at desmos.com. I'm not writing that very neat. If you graph it, and that's how we did them in the homework. We just went to desmos.com and you would grab it. But on the exam, you won't be able to graph, so I'll just give you a 0. So on the exam, I'll say, here you go, x equals 2 is one of the zeros. So as soon as you know that, or you see it on the graph when you're doing the homework, but on the exam, I'll just tell it to you, x is 2, then you go ahead and go into synthetic division. You put your 2 here, because they gave you that one. That means 2 goes in. 2 is a 0. That means 2 will divide in. And you write down your coefficients, 8 minus 6 minus 45 and plus 50. All right, and then bring them down. 8 multiply 2 times 8 is 16, add them up, 10. 2 times 10 is 20, add them up. Minus 25, 2 times minus 25, minus 50, 0. Makes sense, the remainder should be 0 because 2 is a 0, which means it divides in with remainder 0. That's why we call it a 0. Now you know why we use that other name. It's called an X-intercept, a root, or a 0, because you divide it in, it's got a remainder of 0. Okay, so what's left then? Well, what's left is these guys, 8x squared plus 10x minus 25. That means we have y equals that times x minus 2. Remember, you take the opposite of plus 2, opposite. So what we've done so far is we've factored or broken down the original x cubed function to be an x to the first power, x minus 2, because I told you 0, x equals 2 is one of the zeros, or you could see it if you graphed it. And then we divide, we say, well, x minus 2 times what is our original function? I divided the original function by the 2, by the x minus 2, and this is what I got. So that means those two things multiply. So it'd be like if I said, hey, I've got 10, and I know 2 goes in. Well, how many times does it go in? 5. So you'd say, oh, it's 2 times 5, right? When you divide, the answer you get, those are the two things that multiply to be your original. That's what we just did. We had the 8x cubed, blah, 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 originally. They told us that 2 is a 0, plus 2, which means 2 goes in. You can see it on the graph, 2 hits at a height of 0. I divided, and it went in this many times. That means x minus 2 times this is my original function. Okay. Great. Now what? Well, now I need to break it down a little further. I've got to take this piece of the puzzle and break it down. So I'm going to do the quadratic formula to break it down further. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So plug in, this is a, b, c. Negative b, negative 10 plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so what do we have there? Negative 10 plus or minus the square root of 100. Negative times positive times 2 negatives is positive. 800 all over 16. And coming up here, what do we got? Negative 10 plus or minus the square root of 900. 100 plus 800 is 900. And then we get negative 10 plus or minus, that's 30. If you take the square root of 900 on your calculator, you get 30. And so what that means, x, is I'm going to do the two options now. Negative 10 plus 30 over 6, or negative 10 minus 30 over 6. So that's x equals, let's say, 20 over 6, reduce it, divide by 2 top and bottom. 10/3. Whoops, this should be a 16, shouldn't it? I'm messing up here. 16, 16, 16. So that's, I should have divided by 4, top and bottom there. And I get 5/4. The other one, is that negative 40 over 16, divide by 8, top and bottom. Negative, what's that, 5/2. Those are the other two x values. So they want all three x values. I gave you the x equals 2. That's what I'll do on the exam. And then the other two are 5/4 and negative 5/2. Those are the three answers they want you to give.